Hello, welcome to Cracking MBA. Today we're going to talk about progressions, and in progressions we're going to talk about arithmetic progressions. We're going to talk about the basics of progressions and explore the different types of progressions which are arithmetic progression, geometric progression, and harmonic progression. In this video, we will just discuss about arithmetic progressions and reserve the discussion of geometric and harmonic progressions in the subsequent videos. So an arithmetic progression is nothing but a series of numbers which, if they have a common difference, say d, we can express that series by using the seeded number, which is the first number, and by incrementing each subsequent number in the series by the common difference. Either you increase it by common difference or you decrease it by the common difference. Now d can be any real number. Now let us look at an arithmetic series as follows. So on the right side, if you see, we can see the arithmetic progression called 2, 4, 6, 8, 10, which is nothing but a familiar even number series. Okay, so this is a simple arithmetic progression with a common difference of 2. So if you see the difference between each of those numbers, it will always be a constant number of 2. Now it need not always be increasing, it can also be decreasing. Okay, so if you see the next series, which is minus 7, minus 4, minus 1, 2, 5, this is basically an arithmetic progression with a difference of 3. And on the left side it is decreasing, on the right side it is increasing. Okay, so unless we have a specific number of terms which are given, it can increase or decrease on either sides. It can go up to minus infinity to plus infinity. So if you want to express an arithmetic progression, it can be expressed in an algebraic format as a comma a plus d comma a plus 2d, so on up to a plus n minus 1 into d. Okay, so if you want the nth term of an arithmetic progression, it is nothing but a plus n minus 1 into d. So suppose we want to find the 8th term of an arithmetic progression, it is nothing but a plus 7 into d. Okay, now let us see how this is applied using this progression 3, 6, 9, 12, so on. Okay, here a is equal to 3. Okay, if you look at this algebraic format, a is equal to 3, which is the first term. D is nothing but the difference between each of these terms, which is 6 minus 3 is 3. And the nth term is nothing but a plus n minus 1 into d, which is 3 plus n minus 1 into 3. And let's verify this to calculate the fourth term. So the fourth term is nothing but 3 plus 4 minus 1 into 3, which is 3 plus 3 into 3 is 12. So the fourth term in the series is also 12, which is correct. Okay, so the fourth term is nothing but a plus 3d. Similarly, if you want to calculate the 100th term without actually expanding the whole progression, we can directly calculate it as 3 plus 99 into 3, which is 300. Okay. Now let us calculate the sum of n terms of an AP. Now if you want to calculate the sum of n terms, there are two formulae. One is n by 2 into a plus l, which is nothing but the first term plus last term. That is a simple formula. Other one is n by 2 into 2a plus n minus 1 into d. Okay. So the first formula is considered when you know what is the first term and when you know the last term and you know the number of terms. So you use the first formula. You use the second formula when you don't know what is your last term, but you just know what is the first term and what is the common difference and how many terms are there in the AP. Okay. Now, what is an arithmetic mean? So arithmetic mean is nothing but if we denote three numbers by a minus d, a and a plus d, the arithmetic mean is nothing but the average of those three numbers, and can be typically got by calculating average of a minus d and a plus d. So typically it is a. Okay, so if you look at an example, what is the arithmetic mean of 3, 5, 7? It is nothing but 5. Now how do we apply this arithmetic mean concept? We typically use it in the concept of averages. So imagine if you have an arithmetic progression, you can directly and simply calculate the average just by observation. We don't need to even put our pen on paper. Okay, let us see how we can do that. Suppose I have an arithmetic progression with having odd number of terms and arithmetic progression with even number of terms. Okay, so if I have an arithmetic progression with odd number of terms, say for example 4, 11, 18, 25, 32 is an arithmetic progression with 5 terms. Okay, now here just by looking at it, I can see the arithmetic progression nothing but this middle term, which is 18. No calculation. Similarly, the arithmetic progression of the average of an arithmetic progression of even number of terms, which is 4, 11, 18, 25, which has a common difference of 7. Okay, the average is nothing but the average of the middle two terms, which is 18 and 25. Okay, so simply the average is 21.5 without even calculating the sum of these terms. So if you have a series and you know that it is in an arithmetic progression, just you have to identify, is it an odd number of terms or even number of terms. If it is odd number of terms, take the middle term. If it is even number of terms, calculate the average of the middle two terms. Okay, now let us solve some numericals so that you can apply the concepts we have learned so far. A school has been operational from the year 2000 or from the year 1995. Every year, number of students joining the school is increased by 150. Initially, when the school started, there were 250 students. What is the batch size of the school in 2016? Okay. Now, we want to know the batch size of the school in 2016. Okay. This is an example of an AP as the series is 250 in 1995, 496, 550 in 97, so on. We are interested in the 12th term because the first term is 1995 and the 12th term is 2016. Okay. Now you have A, now you have D. What is the 12th term? A plus 11D. Okay. Substituting it, we will get 1900. Okay. So this is how you can apply the concept of arithmetic progression in solving this kind of question. Now let us look at another type of question. A school is conducting a survey to analyze the average performance of their students from 5th to 10th standard in math subject. They are taking the average of their marks each year from 5th to 10th standard. What is the average of the following students' marks? Okay, so students' marks are given from 5th standard to 10th standard as 180, 210, 240, 270 and 300. Now we need to calculate the average of this. Okay, so like we discussed before, the average of an AP, now we can clearly see that this is an AP with a common difference of 30 with an odd number of terms, correct? So this is an AP with a common difference of 30 and odd number of terms. So and as we discussed before, the average is very simply the middle term, which is 240. That is the faster approach. Okay, the slower approach is to actually calculate the sum of the AP as n by 2 into a plus l, which you will get 1200, divided by the number of terms, which is 5, you will get 240. Now this is a long process, okay, and you're consuming time, whereas the first approach is the faster way. So if you know the exact approach, then it's very fast to calculate averages of especially series in progressions. Next, let's look at another type of numerical. Calculate the sum of all numbers between 100 and 800 which are divisible by 7. So let us first try to list out what are the numbers which will be lying between 100 and 800 which will be divisible by 7. So we will get them as 105, 112, 119, 126, so on up to 798. So clearly this is an AP which A is equal to 105 and D is equal to 7. And L is equal to 798, which is the last term. Now the sum of an AP is nothing but n by 2 into A plus L. So if you substitute this, we will get now in this one we don't know value of n, right? So they have not given how many such terms are there between 100 and 800 which will be divisible by 7. So to identify n, let us substitute it as n L is equal to A plus n minus 1 into D. So L is 798, A plus n minus 1 into D is 7. So solving, we will get n is equal to 100. So there are basically 100 terms. Now calculating the sum as n is equal to, sum is equal to n by 2 into A plus L, we will get the sum as 45150. Clear? Now let us look at a different type of question. So here we are saying sum of an AP is 1395 and we are, how many terms are there in the AP such that the sum is 1395. Now the series is given as 3, 6, 9, 12 and so on. Now here A is equal to 3, D is equal to 3 and the sum is 1395. The terms are all in AP because they have a common difference. So the sum is nothing but n by 2 into 2A plus n minus 1 into D. Okay. Simply we substitute the values provided for A and D in this equation and we will solve it to get the value of n as 30. Okay. So this is how you use your formulae to solve the questions. Next is, what is the sum of the following terms? So this is an interesting question. So here we are observing that it is not like looking like a regular series. Okay, they seem to be a different pattern. So here clearly we can see that this particular series can be expressed as a sum of two different AP. One AP is 1 plus 3 plus 5 plus 7 up to so on up to 50 terms. Another AP is minus 2, minus 4, minus 6, minus 8, so on up to 50 terms. So if you add these two terms, okay, the first one has a difference of 2, second one has a difference of minus 2. So if you add these both, okay, separately by taking n by 2 into 2a plus n minus 1 into d formula, we will get the sum as 2500 and minus 2550, and adding them you will get minus 50. Okay, so this ways, if you have a question where you have a different kind of series, just try to see if you can arrange them in the format of two different APs. Okay, now let us look at another question. There are 5 numbers in an AP such that the sum of first and fifth numbers is equal to 8 and the common difference is 3. What is the series? So this question is primarily to help you to identify how we can represent the numbers in a series, okay, the generic format. So if we have five numbers, we assume that they will be in the format of a minus 2d, a minus d, a plus d, and a plus 2d. If we have only 3 numbers, it will be a minus d, a, and a plus d, okay, and so on. So now we are given that a minus 2d plus a plus 2d is 8, so a is equal to 4, so also d is equal to 3. So just substituting in this, we will get minus 2, 1, 4, 7 and 10. Okay, so this is just a brief overview about arithmetic progressions. We have solved some different types of numericals also. You can strengthen your knowledge by solving some of the real actual CAT questions in the mock test on our mobile app. Okay, you can find it on the Play Store, and you can also reach out to us if you have any questions on our forum, which is also on the mobile app. Okay, thank you very much and hope to see you in the next session on geometric progression.